Alright, we're going to be going over how to solve exponential equations with common bases. Now, as the title suggests, the whole goal is I want to make my exponential have the same common base. So like in this exponential, the base is the 5, is the number we're taking to the power in order to solve the problem. I've provided you this chart on Google Classroom. You can go ahead and write it on a separate sheet of paper though, if that's going to be easier than looking at the Google Doc. The way that you just read this is the top numbers tell you the power that you're taking the number to, and then the side numbers tell you the number that you're taking. So for example, 2 to the 4th power gives me 16. 5 to the 3rd power gives me 125. It's going to be helpful to be able to reference this chart so that you can quickly figure out which common bases it is that you're looking for. So for example, on this first one, 5 3v minus 2 equals 125. Now I want to ask myself, how can I make this a common base? Well, I know that 5 to the 3rd power gives me 125, so I'm going to go ahead and rewrite using that. So I get 5 3v minus 2 equals 5 to the 3rd. Now this is really asking, let me zoom in so you can see this a little better. There we go. So this is really telling us 5 to some number, we don't know it yet, it's 3v minus 2, and I don't know the value of v yet, equals 5 to the 3rd. That means this whole little phrase, 3v minus 2, has to equal 3. So let's go ahead and set that up. 3v minus 2 equals 3. Now all of us should know how to solve this. This is an Algebra 1 problem now. So I add 2 over to the other side to get 3v equals 5, and then divide by 3, I get v equals 5 over 3, 5/3. I just rewrote that, that's the same thing. 3v equals 5 over 3, 5/3. And then I am good to go. Alright, next one. Let's say I have 4 to the negative a power equals 1 over 16. Now what do I already know about negative exponents? They become fractions. So this is really 1 over 4 to the a. 1 over 16, how will I get that to have a common base of 4? Well, I should know 4 squared gives me 16. Now they have a common base. Common base and both being under 1, you're still good to go. So 1 over 4 squared equals 1 over 4 to some number. That means a has to equal 2. Don't overcomplicate it if you get a problem like that. Now don't freak out either just because you get a problem like this. We do know how to do this, so I want to ask myself, 6, 25, and 25. How can I get them to have a common base? Well, let's look at my chart. Oh, 6, 25, and 25. Both I can make a base of 5, so that becomes 5 to the 4th power for the 625. And then we still keep it times negative 3p. Times 5 to the 2nd power times 2p minus 2 equals 5 to the 2nd power. Now you can simplify these exponents at any stage. I want to go ahead and just simplify them now just so that I'm not having to bother with them being super messy later. So 4 times negative 3p, that gives me negative 12. So I've got 5 to the negative 12p times 5, and we go ahead and distribute that. 5 to the 4p minus 4 equals 5 squared. Now I'm not quite done with it yet. I still have 2 numbers with a common base, but that's still what I want. Because whenever I multiply numbers, what happens to their exponent? Well, if I had 5 to the 3rd power times 5 to the 2nd power, remember from previous units, that's 3 5s multiplied by itself times 2 5s multiplied by itself, which simplifies down to 5 5s being multiplied by themselves. When I multiply exponents, I really add them. So that means that becomes 5 to the negative 12p plus 4p minus 4 equals 5 squared. Now this looks like my other problems because now I have common base, so I know 5 squared equals 5 to some monstrosity. So let's go ahead and set the monstrosity equal 2, 2. Now this is an Algebra 1 problem. I can simplify from here. Negative 12p and 4p combine to make negative 8p minus 4 equals 2. Go ahead and add the 4 to the other side, and then divide by negative 8. And then can I simplify that fraction? Absolutely. 2 goes into both the top and the bottom, so then I get that that equals negative 3/4. Alright, I'm going to do another example after this, but if you want to go ahead and save a picture of this, let me get that zoom so you can go ahead and save a picture of that if you want. Alright, I'm going to go ahead and move on to the next problem. Now you might also come across problems like this, where I've got two numbers multiplied by each other equals 1. Now remember, we're wanting to get everything in this to have a common base. So what I would recommend going ahead and doing with problems like this, go ahead and just make it where you're going to have both two numbers that you can actually turn into a common base on both sides. So go ahead and you can just divide over the 64, divide over the 64. And so then I end up with 1 over 16, 3n plus 1 equals 1 over 64. Now I've got something that I can work with a lot easier. Now 16 and 64, both of those we can turn to a common base with what? We want to probably use, let's look back at our chart, we want to probably use who we're looking for, 16 and 64. Both of those we can turn with a base of 4. So let's go ahead and do that. So that becomes 1 over 4 squared to the 3n plus 1 equals 1 over 64 is the same as 4 to the third. Now this still is not quite looking like how I'm used to it. But if I have this whole thing to the 3n plus 1, what's 1 to the anything? Still just 1. Doesn't matter what 3n plus 1 is. So I can go ahead and rewrite this like I'm expecting it to be, where I've just got 1 over 4 squared. And now I'll go ahead and take 4 squared to the 3n plus 1. Be sure to use parentheses, equals 4 to the third. Now I can work with this easier. I've got a common base of 4. They're just both happen to be underneath a 1. That's fine. And I can go ahead and set their exponents equal. So I know 2 times parentheses 3n plus 1 equals 3. Go ahead and distribute. So I get 6n plus 2 equals 3. Subtract over the 2. I get 6n equals 1. Divide by 6, I get 1 equals 1/6. Let me write that a little bigger, 1/6. N is 1/6, and I am done. So let's recap a little bit, because that was a lot of information at once. If you're good, you can go ahead and just move on to the practice. So I'm going to always be looking back at my reference chart, which you either wrote down or you can just look at the document on Google Classroom. The idea is, in order to solve these problems, I want to make sure they have a common base of some type, so that I can go ahead and just set their exponents equal to each other. I will occasionally need to use my exponent rules, like knowing that a negative exponent becomes a fraction, or knowing when I'm multiplying two numbers with a common base, I could just add their exponents together. And then once you get the two bases on both sides of the equation, go ahead and just set them equal to each other. Boom, you're done. Go ahead and just solve an Algebra 1 problem. If I've got it equal to 1, I can go ahead and divide over a number to the other side, and that way I've got the common bases on both sides of the equation. If I wanted to instead, I also could have used an exponent of 0, because any exponent of 0 equals 1. Take your pick on which method you like better. I personally like having the common base on both sides of the equation still, just so I can see that visually. But if you want to just set it equal to an exponent of 0, that's fine too. And if you want more information about that, you can contact me on Google Hangouts. I can show you some alternative methods. Good luck. You can reach me on Google Hangouts, Flipgrid, or texting anytime.